Since we took over Pad B from the shuttle program, we have renovated, repaired, replaced, or removed almost every single thing out there, every system out there. When you look at Pad B, it looks just like a hill with maybe some radio towers. It's very deceiving to the eye because there's a lot of very complicated systems around the pad perimeter and actually underneath the pad surface. We have a lot of mechanical systems under the pad surface as well as instrumentation system. So we started this renovation by really looking at some of the big projects that had to get done before other things could get started. One of the first things we did was to erect some lightning protection towers. These are 600-foot tall towers that will provide lightning protection for the vehicle while it's sitting out the pad. At the time we were under Constellation program, we did not know what size vehicle was going to come. We started the design of these in 2006, 2007 timeframe. So they were sized for any vehicle that could leave the vehicle assembly building. And this is a good example of where you have to make some engineering assumptions when your requirements aren't given to you on a silver platter. We didn't know what the vehicle was going to look like, but we were pretty sure we were not going to replace the vehicle assembly building. So based on that assumption, we could begin the construction and we could get it done within our timeline to do the job. After we did the lightning tower system, we started to demolish the fixed service structure and rotating service structure. These were utilized during the shuttle program, and this has provided all the access to the vehicle, to the shuttle while it sat at the pad. Under Constellation and continuing on in GSDO, we are going to a clean pad concept, which is where you basically have a lot less infrastructure on the pad surface. The vehicle doesn't have to stay at the pad as long. While the beachfront property that the launch pad is located on is absolutely beautiful, it is also very corrosive. And so all of that structure we have found requires quite a bit of corrosion control. So going to a clean pad concept, you eliminate that and you can keep as much of the equipment as possible inside the vehicle assembly building on the mobile launcher where it's sheltered. You can also make all your connections to the vehicle inside the vehicle assembly building rather than doing it out at the pad. You can have much more access in the vehicle assembly building than you can there. And then the idea is to minimize the stay. So we started demolishing the fixed service structure, rotating the service structure, going towards that clean pad. It was very emotional because of the history. Obviously, there's a considerable amount of history. And the timing was very unfortunate because it was happening at the same time that the shuttle program was ending. So a lot of people looked at that as a visual evidence of the shuttle program ending. The two were actually independent. We had already started a Constellation program. The timing was unfortunate in the public eye. It was quite difficult. And even for the people out here, when you actually saw the thing being torn down, it was difficult. But we focused on that it's a step towards the future. And that's really what we tried to get the message out to everybody, that this was clearing the path literally for the future. So once we got that done and we put that behind us, we started to, was around the time that Constellation was canceled, and we needed to start focusing on things that were independent of whatever vehicle was going to come. The vehicle connects primarily to the mobile launcher, so we connect to the mobile launcher. We're kind of like the RV park, and the mobile launcher is the RV. A very glorified and beautiful RV park, but it's none the same. It's a similar concept. So as anything that was unique to the vehicle would be on the mobile launcher. We had the luxury of not being specific to the vehicle. For example, we knew that our instrumentation systems could be updated. We knew that we needed a weather system, regardless of what was going to launch off Pad B. So we started replacing a lot of the electronics and instrumentation systems out of the pad. We started removing cables. We had Apollo-era cable all underneath the pad surface, inside the instrumentation rooms underneath the pad surface. We took out over 300 miles of copper cable. That's enough cable to get from here to the keys. And this cable was not your simple copper cable you'd have in your house. Some of these cables would take 2 men to pick up 10 feet of it. So that was a considerable amount of weight. But there were cables that were abandoned that no one even knew where they went because they had been around for 40 years at the time. So we took all the cable out, replaced everything with fiber optics. We did this work between the programs, knowing that something was going to come, but at the time we weren't sure. But it was really important to keep the workers going. It was really, really important to let everyone know that something was going to come and to start continuing to work towards that future. And so all the work that we did during that time was productive. It gave us a leg up when we got into GSDO, and it also helped keep the workforce engaged. We started, as GSDO became, more of a reality, we started focusing on what things needed to get done, because we were also going towards a multi-user spaceport. So we've replaced our flame deflector and the flame trench. The flame trench is kind of if you think of a big, literally a trench inside the pad surface, and the deflector is kind of an upside down V. And all the exhaust from the rocket impinges on that deflector and gets deflected down the trench, and it goes away from the pad surface and away from the vehicle. We wanted a deflector that could support not only the SLS, but anything else that smaller than that might launch off of Pad B, because we wanted to go to this multi-user spaceport. So we had a design that was optimized for SLS, but able to support the other programs. So we had to take out the old deflector. That was a separate project. And then also, so we started to build the new deflector. We're actually in the process of finishing that job now. Another thing we did with that was to look at the bricks in the trench. The bricks were in there, the original bricks, 50 years old, had started to come loose during shuttle launches towards the end of the program. And so there was a lot of concern of, would this last us in the next, going into the new program? And when you're starting a new program for 20, 30, 40, maybe 50 years out, you obviously want to do everything you can so that you don't have to stop and redo like a major project like that. So we, along with the deflector, we took out the old bricks and have just finished putting in beautiful new bricks on the north half of the trench. Because SLS has a different rocket configuration, all the exhaust only goes to the north. Under shuttle, we had exhaust split on the deflector, somewhat north, somewhat south. So we saved considerable money by only putting brick in for the north side, and we've just coated the back. So those are some of the big ones. We have replaced our environmental control system. This is the system that provides, we compare it to a HVAC, a heating and ventilation air conditioning system. It provides all the conditioned air to the vehicle, but it's really your HVAC on steroids. This is a very complicated system. It controls the humidity, it controls the pressure, it controls the temperature to very, very tight tolerances, and it has to provide it to each of the individual compartments on SLS and Orion. Speaking of Orion, we have air and we also have GN2, because before launch you want to have a purge, and we need to switch over from from the air to the GN2 before launch. We don't want to provide GN2 to the crew cabin, so we have dedicated circuits to the crew cabin of only air. So this is a very complicated system that we've been replacing for the last few years, and that's one of the last things we have to finish out the pad before we're finished. So all along those are some of the big rocks that went in the jar. Because of the size and the scale of these projects, we've had to do these large projects kind of one at a time in series. But all through that, we have done a wide number of smaller projects in parallel with that. And so, like I said, we have touched everything out there. When you go out to the pad, I can't see anything that we haven't brought up to date and ready for the future. The fortunate thing of when this happened, when the structure got burned, is that following Ares 1X, we were going to begin demolishing it. So nothing really had to go in and be repaired. It was kind of just abandoned until the demolition project began. So one of the upgrades that we've done out at Launch Complex 39B, learning the lessons from previous programs, is that living in Florida, we get a lot of bad weather. We get a lot of lightning capital of the world. I mentioned before, we had erected lightning protection towers. Those provide a catenary system that provide lightning protection to the vehicle. In previous programs, when there is a lightning strike anywhere in the area, you have to make the assumption that the lightning strike happened on the vehicle. So you have to go through all the vehicle systems and do testing. This takes several days. So going into Constellation program, there was the decision to put in a new weather system that could monitor these strikes, and locally developed a system in-house that could pinpoint where the strike happened. So we had some great engineers that worked on this technology, and this was one of the projects that we continued between Constellation and GSDO in that gap time, because we knew whatever vehicle that was going to launch out there was going to be susceptible to exposed to lightning. So this system is really amazing. We have sensors all around the pad perimeter. It's a 2-mile perimeter, and at different locations we have sensors that can pick up this electromagnetic activity when there's a storm. And then on top of the lightning protection system, we have high-speed cameras that are always recording out at the pad. And when those sensors, because they're high def, high speed, they're constantly just going through and recording and dumping and recording and dumping. But when the sensors pick up some activity, they save that data and set it aside, and then the team can come in and post-process that, and they can show you exactly where the strike occurred. So no longer is it in a couple of acres. It's this struck this specific location. They have sent me pictures of a lightning strike on the telephone pole outside my window. We just got some from a few weeks ago of them striking the wires out of the pad. This system has far exceeded anyone's expectations. The design team has done an incredible job on this technology and it has proven it out, and it's really changing the industry on what we can do in lightning detection. And this is state of the art of what we've put out there at Pad B, and they're starting to translate this technology to others. Dr. Carlos Mata was a design engineer that led that up and has done great things with that. And so that's really going to enhance our capability as we go forward in the future, because it's always about trying to get every possible opportunity to launch that vehicle. And if this keeps us from having to scrub and spend some time testing systems on the vehicle because we know it didn't strike the vehicle, instead it struck outside of Regina's office, we can continue to work, and that's a good day.